Oh yeah, here we go. Start. All right. So I, you'll notice that the spreadsheet jumped and changed a little bit. So what it did is I used to have A and B values here and here, but I decided that I wanted to make a nice fit parameter table. So I'm going to take these estimates here, copy, and I'm going to use them as seed values and put that there. And for B, I'm going to copy and put that and paste values, right? Now, we have the C and the eccentricity and the so-called linear eccentricity that's outlined in the manual and the supplementary file, the PDF that says ellipses for 1100 labs. And so basically, and so the linear eccentricity, or C, which is the distance from the center to the focal point, and then A, you notice it's half the long axis, which we discussed in the previous video, and B is half the short axis, so we call that the semi-major. A is semi-major, B semi-minor, and and I can't find a drawing that gives the whole eccentricity, the little e, as something drawn on a picture like that, which pisses me off. Now, originally, I used E as C over A, but I want to just have A and B to be my two fit parameters. So I'm going to, instead of, and I still need C though, because that tells me the distance from the focal point to the center. I want to find out where that goes. And so, but I'm going to use this definition of 1 minus B squared over A squared, square root, for my E. And there it is. And when it's so close together, of course, everything gets stepped on. Well, by those little messages, the tooltips. Let's zoom in on that. And then now you can see it better. Okay, so now we're getting there. And so I have my fit equation. So that's here, right? R is a function of theta, and we're using it from the focal point, just as it's shown here. And so that means we multiply by the A value here times 1 minus the eccentricity squared divided by 1 minus, so it's in the document and I put it in the lab manual. When you go from this focal point, you use 1 minus the E cosine theta. And then, of course, the theta here is the in radians. There we go. And then, as always, I drag. Oops, something went wrong. No, I want to undo that. I didn't grab the fill handle properly, so now I have that. And as always, just as before with the actual data, if I want to plot it, I have to create X and Y values for Excel. So the cos and the sine, except now the radius that, the vector that I'm getting the components for is the fit radius, as opposed to over here, it's the data radius. And then once I figure out those, Once again, I just fill them. And I also now can do my residuals. Data minus the fit. That's the R values, the magnitude of the vectors, and our standard residual squared. The rest of this is for testing Kepler's laws. And remember I told you I couldn't figure out how to do the area? Well, I did. So you don't have to print this and draw lines on it. Okay, so why don't we just make believe we don't have a graph? And so we have our X and Y data, and yeah, that's it, to plot that. And so, and we've done it on the previous page, of course. Oh, right, but we don't, right, in principle, and in fact, what you guys should do, give me a minute. Yeah, because you guys don't need this business here, right? Basically, you're going to end up with this, with the 52.5 degrees, right? So what you want to do then is you simply want to make a copy of this. And then when you do that, let me demonstrate it to you. I'm just going to move it to the end. Make a copy of it. And then everything is waiting there for you. And you just won't have this business here. And then you can add in, yes, you guys can add in this stuff. And so A1 and A2 was the left side and the right side, the minimum and maximum values. See, I've shown you that already, I think, but I'll just go back through it one more time. Max, then I take the total distance from those two and divide by 2, and same thing with and it's the y values, see here. And oops, see the x values and the y values. Then I can, and one could argue that maybe I should revert this could be in a different order. It's up to you. And so, oh yeah, but first I have to copy paste those estimates into there, the guesses. Then I can construct this and construct the E and the fit equation. This, well, I'll go over this, but let's see, F1x, F1y, and I'm just not exactly sure what these are, but this is simply the this. Well, we'll get there. Well, I'm jumping ahead of myself. All right, so now I got the fit. So now let's go to solver. And solver, I want to minimize the sum of the residual squared. And now I just pick A and B there. And I say solve. Now, of course, that's great, but we forgot. We need to, so let's do select data. And I've got other stuff here. And so let's remove that for a minute. So as I said, I put some other dots on here, and I'll get to that. So we want to add our fit to it. There's no error bars. That's nice. Select data. We add. So that's going to be the radius from the fit. And the x values are these. No, wait, excuse me. Of course, they're this. And then the y values are here. And of course, it gives us a line with, yeah, I wonder if you can edit the No. So now I have to get that sidebar, and there's a toolbar in my way. I don't know if you see it. Radius from fit, solid line, and I always like using red, but there's no requirement. Make it small, maybe a tad bigger than that, and then I want no markers, none, and I think that I'd like to make the let's see. I want the series Y data. Yeah. I want to make the line a little bit thinner here as well. Yeah, I like that. Okay. Okay, so now you see we got a pretty nice fit. And this is, at some point, I'm going to go back and do it with 53 degrees. All right, so now we have our best fit A and B values, our best fit of eccentricity, and our best fit of the linear eccentricity. So, F1 of Y, F1 of an X and Y. Of course, and the way, I get it. This is, by definition, there's 0, 0, right? That's the way it's set up. So then the center point is at x equals 0.66, which is this. And so, what are that? O3 plus M2, right? Because I always try to make my spreadsheets generalized, right? So this way, if I change this somehow, I'd put it there. Okay. And then the coordinate of that is just 2 times, right? Because that's the definition of C. Let's go back and take a look. Right, so C, little c, so if I add little c to that, I get to the center, and then if I add little c again, then I get to the other focal point. And I like the way it's within the same document too. They switched the nomenclature for F1 and F2. Oh boy. And we'll get to, okay, I guess now let's see how we put those on there. I just actually added them as data series. So the center, and you see that's the label, and then the x value is, I called it center x, center y. So the x and y, and then for each one of those, and I just altered. I just used the so format, like what is that? F1 point, F1, I guess, and then I made the marker bigger, size 10. Right, so in fact, one could add a legend. And for example, that could use some cleaning up. All right, so now we have all those things. And now we can, and of course you write all this up in your logbook. And now we can go through and look at the analysis questions. So I'm going to stop this video and start a new one for going over the different questions in the manual.